Welcome back. So in the last video, we did the 3D analysis in Ansys Maxwell, the transient of the toroidal transformer. In this one, we're going to do the exact same thing, but with the 2D analysis. And this can be imported from the PEmag model that we made in the first video. And so let's get into it. Here we are. It opened PEmag back up. I'm going to go modeler, Maxwell link, eddy current. This one we're going to do 2D, so it doesn't let us select any of this stuff over here. Open circuit, we'll click OK. It shouldn't overwrite the 3D model that we just made, so I'm just going to click yes. So for the 2D model, it makes two different models, so this frontal and lateral ones. We're going to do the frontal. So here we are, here's the 2D view. It's been generated, and we need to do all the same stuff we did before. But since we've already done it, and I don't want to do it from scratch, what we can do is open the 3D view, and then we can copy and paste some of the things over, like the material properties and the Simplorer schematic. All right, so here it is. We have the tutorial 7 one here is 3D and 1 is 2D. So we can just rename those. We'll do rename. So we're going to copy the Simplorer. Just click there, Control C, click up here, Control V. So now we have Simplorer schematic copied over. And it breaks this excitation link, but everything else works. So then if we look in these definitions here, there's a few different ways to do this, but we have this material here, Mag Inc. MPP 200. So we can copy that one, put it up here. So that doesn't work. Okay, since you can't copy and paste from there, we'll go back, and if you go into project here, source for mesh, get into this model section here. We have the core material, so we can get the properties for that. And this is where we would pick that material. What you can do is go over to this other one, and when you're in the materials here, we can get this property here, export, I think, yeah, export to library. And that'll bring you here to your personal library. And then you can save it here. Call it Mag Inc. MPP 200. And we'll save that. Yes. So now we created a new library in our directory on this computer. So we can cancel this, go up here to the 2D version, properties, and now we look for these three dots. We want to get personal, here it is, MPP over here. And this one shows the MPP 200 here in our personal library. So we can double click that and wait for a minute. And here it is. So it showed up. So now these guys are going to want to do what we did before. Select them and group them before we give them properties. Make this one primary. And now we're going to assign these materials copper. So now that the materials are set up, we can, it looks like this project manager kind of went full screen over here. Oh, there we go. Hit the little tack button to get that back. So now we're ready to set up the simulation settings. So we go over here to solution type, make that transient. Then we want to make sure that we have the extra settings for the inductance and the core loss. So the inductance was Maxwell 3D, design settings, and matrix computation. So that one's still there because we did save as default. So we don't really need to do that one again. So the next one is the core loss. So that's right clicking on excitations, set core loss. Want to make the core. So OK. And then there's also the eddy currents, which we're not really using, but we can set that anyway. Click OK. Now we need to add a solution. Again, we're going to do 2 microseconds. And the step will be 100. Save every field. Now we have to set up the excitations. And these are a little bit different because instead of having one full loop as one object around this, in the 2D we have 2 circles representing one loop of wire. So you'll notice there's actually twice as many of these in here. There's, what is there, 20 labeled C1 with a number, and then there's 20 that have a P. So the P is the positive. So if you look at the excitations here, see direction, negative, and it's really hard to see it here. Like this is pretty unintelligible. It's like a up or a down round arrow. And you just have to look over here and see if it's negative or positive. If you double click this, you can see it here, it's negative or positive. So these guys are negative, and the ones with a P are positive. So that makes it kind of easy to remember. So we're gonna go over here. We're not gonna use any of these excitations here because they are not the right type. It's a current excitation, but you can't assign it to the terminals. So if you go over here, we need to make a winding primary and a secondary. So you right click on this, see it, there's no add coils here because these are not coils, I guess. So we're going to delete all of these and we're going to make new ones here. So you have to select this geometry stuff, assign excitation, coil. See those ones over there are currents, not coils. So we need the coil, and we're going to give it the name of primary. Well, we could do like N for negative, and this is going to be polarity negative. We'll do this next one here. Assign excitation coil, primary P. Make it positive. And the same for the secondary. So now that we have those, we can add them to these windings here. So you want to do add coils. Terminal's not assigned to anything. For the primary, we just want all the primary ones. And then for all these extra current ones, we just want to delete those. So just click on the top one and hit the delete key. And you just have to keep hitting that a bunch. It won't let you select all of them. And there we go. And if you accidentally do stuff in here or wherever, you can do Control Z and it'll bring the last one back. So now that we have that, see we have 0 milliamps here. We want to connect up the Simplorer. So we'll go over here and we just have to delete this. But what we want to do first is remember what we had in here. So we have M1AI, and then down here we have these times here. I'll just copy this. We're going to delete this one. We're going to import it again and extract. So this will extract a link to the ones here for this 2D simulation. Make these A and B, and we're going to make this 1.9, 1.902. Should be milliseconds. All I have to do is place that, and see if we can push it. It says there's no sim data, so we need to save this and run this simulation again here. All right, now that that's done, we could double check the results just to make sure it makes sense. Looks like it's doing about the same thing as it was. So we go back here and open this up and we can push the excitations. So that was successfully sent. Okay, and now we go back over here to the primary. We should see the piecewise linear formula in here now. And if we go up to the, let's see, design data sets, and we can see the waveforms in here. So we'll save that. Now this one, we can clear these messages, runs a lot faster than the 3D. So we can go up here to simulation, do the validation check, and it's just saying the only thing we haven't done yet is the mesh, which we know. So we'll do the same thing as last time. We're just gonna, we can do these HPC settings again. Notice in here, you have to set these again. I've already reset it to 4, but I think it starts off at 3. You'll notice there's no option for the GPU. So this just uses the CPU. And we can analyze all. As you can see here, the time it's going through. This is actually real time. It just solved the whole thing. So that didn't take very long. Definitely not like the 3D. We'll check here on the profile. So that was 19 seconds. So it's basically 60 times as fast, I guess, or instead of 18 minutes, it's 19 seconds. So now we have to set up the plots again. Here are the results and the fields. So go ahead and do that. It's the exact same as before. Rectangular plot. All right, so those are all set up. We can click on these, and there's something you can see off here. This core loss is different, and the inductance is 8 millihenries. And I forgot a very important step here. So when we're in this design settings, you need to go to depth. So since this isn't a 3D model, it's a 2D model, it's assuming that everything on that 2D has a certain depth, and the default is 1 meter. So we need to go back to our core here, and the depth of this core, this height here, is 4.75 millimeters. So we need to change this to 4.75 millimeters. There it is, millimeters. Oh, we don't want to save the default. So that invalidates all of this, and we just have to run the simulation again. Okay, so now we see it's 38 microhenries, so that's better. That's close to the 36 we were expecting. And there, the core loss is back in the microwatts like we had in the 3D model. So now we want to plot the mesh. So we can select all this stuff and right click here, and then we can plot mesh. And we'll call this, we'll just call it mesh 1. So I always forget, but the mesh won't plot. Nothing will plot when your time is -1. So we'll have to just advance it here to like the 3rd data point or so. And now it'll give us a mesh. And we want to unselect here. Now we can see all the meshes. This is the default mesh. So you can zoom in. So it has a pretty fine mesh set up initially, but we can make that a lot finer because this analysis runs really fast. So we'll set up the mesh operations here. Start with the primary, and it is a little tricky on this one. If you do mesh operations, so on the 3D, the on selection is like the surface of the 3D, but here it's like the edge of this 2D. So you're just making the edge real small. So we're going to do the inside selection and length based. For this one, we'll just make it 0.01 millimeters. And we can make these a lot smaller because it runs faster than the 3D. So this is primary. For the core, let's do 0.1 millimeters. So now we have those here. We can save this. Another thing to point out in this simulations here, there's mesh settings. You can just drag the slider to make a finer mesh, sort of an automatic mesh. So there's that option too, instead of adding these in here. And then with this, add it in here. We want to make sure it's saved, and then can right click on here and do, let's see, transient, right click and do generate mesh. So there it goes, and it's done. It didn't really look like it did anything, but we can delete this just to check and select everything again here. We don't want to select that air. We can plot the mesh. And it's still stuck on the simulation here. So I think we need to get the simulation out of there. So right click and do revert initial. So we'll generate the mesh. Okay, so it did. So now we have a much more fine mesh. You can zoom in on here. And the mesh, it is a little tricky to see if it worked or not. So I think the lesson there is just make sure that you get rid of the analysis. If you have one already generated, just revert to time 0. And that way, I said before that you can't see the mesh unless you're at a certain time. And I guess that's sort of incorrect. So you can at time -1, which is like before anything ran, you can see the mesh. I guess maybe only if an analysis hasn't been run or something like that. Anyway, if you have trouble with that, you can also do this slider here. Just do a mesh. It's kind of the same deal as putting these mesh operations in here. So we'll run this simulation now and compare it to the original. All right, that one took a lot longer. Let's see here. We've got profile, 24 minutes. Okay, so we went from like 24 seconds to 24 minutes or something. Now let's see if it made any difference on these plots. Looks like it updated automatically, but we can do update report. So here it is, 2.5228 is the core loss, and our old one here is 2.5190. So it did change slightly. So a couple final points. If you want to see if something ran and you're not getting a plot here, you can right click, and it's easier if you create a data table. So we can do loss, core loss, and this will show you the actual data points. So if you get this and these all say like NaN, not a number, or they're all blank, then there's no data for that. If there are numbers, then you might just need to update the plot or something. So another thing is I've had a few times where the progress bar just gets stuck in the middle of a simulation, and it never really, I think it doesn't even really get to the part where it's actually saying the time that it's going through in the simulation. But it was in the 3D analysis, and it would just get stuck for hours and hours and never do anything. And I just have to abort it and try again. So a couple of the problems that caused that were when I had no insulation thickness in the PEmag, the model that was exported. And so then I think the windings were kind of barely touching each other maybe. So you got to have some insulation thickness. Another thing that I had problems with was in these data sets here. When I tried to do in the core materials, let's see, go back to here, and let's see the core materials. If you try and give it a permeability, edit the material. So up here, if you try and give it a permeability as a formula up here, and then you have a data set, I was having problems with that. Sometimes it would work, and sometimes it would just hang with no errors. And that was because the data sets in here that was linked to it, I think maybe it didn't have enough range of points over enough frequencies or something like that. But you can play around with that. If it hangs, try disabling one of those. So that's it for the 2D transient analysis, and next I'm going to look at some of the AC analyses, frequency domain, and try and extract some of the parasitic inductance and capacitance values. And I'm doing this also with some COMSOL tutorials, so you can compare and contrast the two. And I'm going to start off in the next video by redoing the model from scratch, just so that we have a cleaner model, not using the PEmag model, and we'll do that in 3D and use, so each coil will have just one part. It won't be individual loops for each winding. It'll be one solid part. Anyway, so check that out next, and thanks for watching.